What's up, world? Welcome back to another tutorial. Today we're going to be talking about meshes and how they relate to game objects and why we should use a mesh with a game object and not just put all the vertice and vertex information and the bounding boxes and bounding spheres all inside of the game object. We should totally separate those out. So today we're going to separate those out. We're going to create a mesh library. We're going to make it so we can dynamically make meshes. And I swear to goodness, we are going to be changing the shape of that freaking triangle. Get pumped. Let's go. Okay, so back in our code, you'll note that we have our vertices and our vertex buffer already in the game object. Now let's separate this out because, like I said, we need to put this into a mesh class or struct. So at the very top, I'm going to create a protocol and I'm going to call it mesh. The reason I'm making it a protocol is because we're going to need multiple types of meshes. We have custom meshes. We have Apple meshes, which is like cylinders and cones and all sorts of shapes that Apple provides with meshes. And then we'll also have our own custom meshes. We've already created a custom mesh, which is our triangle using these vertices. So up at the top with the mesh, we're going to store in there the vertex buffer, which is an MTL buffer. And we're also going to store the vertex count, because we're not going to have the count of our vertices in here. We're not going to store the vertices in here. We're only going to store the vertex buffer. And there's a reason for that, because really we don't need vertices in here. Also, what's going to go in here in the future is our bounding boxes and bounding spheres, because we'll create those on the fly as well. But since we moved our vertex buffer into our protocol, let's create our own custom class called custom mesh. And then that will extend our mesh class. And if I kind of do a little quick build here and press this red button, I can get these properties in here. So let's instantiate these. Well, down here in our game object, I already have the initializer. So I'm going to take that. I'm going to put it up at the top. I already have the vertices created, so I'm going to cut that. And I'm also going to put that at the top. And then I need the functions for create vertices and also create buffers. So I'm going to put those in there as well. See, look at that. Custom mesh already completed. And what's kind of cool about this is the fact that if we were to just put var mesh here as a mesh and set that equal to our own custom mesh, and then down here we're doing render command encoder. Down here with our render command encoder, we're doing vertex buffer. Well, we have mesh.vertex buffer, and we have mesh.vertex count. And also we need to instantiate our vertex count. So up here in our mesh, custom mesh, vertex count, we're just going to make that return vertices.count. Clever, huh? Okay, so I'm going to build that, make sure everything builds. I know I went kind of fast. I hope you saw that. Basically, we created a mesh. Then we created this custom mesh class. And now in the game object, we can just use this mesh object to do rendering from them. And if I press play, hopefully we get the triangle back. There she is. So yeah, that's separating out into a custom mesh. Now saying custom mesh doesn't make any sense. How are we supposed to dynamically change this? We're not, right? We need to extend off of this mesh. And so what I'll do is I'll create another class called, we'll call it triangle underscore custom mesh. And then that will extend custom mesh. And instead of doing create vertices up here, what I'm going to do is I'm going to cut the create vertices, like the array out of create vertices, and I'm just going to create them down here inside of triangle custom mesh. And so since it's calling this initializer already, down here I can say triangle custom mesh. And if I press play, yet again, now we can specify out our custom meshes beautifully and gorgeous, back to the same triangle. Okay, so this is, like I told you that this should be easy, right? And pretty. This is not pretty. We need to take this stuff out and put it somewhere. So over here in our libraries, I'm going to create a new file, and I'm going to call it mesh library. That's right, we're creating another library, people. We're going to create a bunch of these things. They're really cool because we need to cache this information. Our game object has these meshes, and if we were to create all of these mesh, like if I were to call this on every game object in the entire game, I'd be creating all sorts of triangle custom meshes. I'd be creating this over and over and over and over again. It's just too much memory. So we need to cache this information, obviously, into a mesh library. So give me 1 second. I'm just gonna set up the basic layout like I did in the past videos. Wish me luck. Okay, so now that looks beautiful, this is just our basic, this is the mesh library we've been creating all along, where we create an enum with mesh types so that we can store into this dictionary a mesh type and a mesh, and then grab that. Actually, this should be private because I don't want to access outside. And then we create an initializer, create default meshes. This will create our default meshes right there, where we update the value to our triangle custom mesh. So we're going to store that one first for triangle custom, and then we have our function to get the mesh add there from here. So once it's created, we don't keep making the same exact thing over and over again. Let's go back to our game object and just kind of let's copy from the triangle custom mesh all the way up to the protocol mesh, and I'm going to cut those out of the game object, and I'm just going to go put those into the mesh library. In the future, I'll probably clean this up and not store it in the mesh library. I'll probably separate all of these out into their own, groups. We'll have a code cleanup episode or something. But for now, this should work, where we have our mesh, our custom mesh, and our triangle custom mesh. Now, I did tell you that we will be creating freaking different objects. So let's do that real quick and prove to you that I'm not going crazy. First of all, before we do that though, I want to do this. I want to say mesh library dot mesh. I think it's like this underscore custom. And we also need to initialize it. So back in our engine, we will need to call mesh library dot initialize. Now give me 1 second. I'm actually going to go through each one of these and make them all capital because I think that it's like the initialization function. So give me 1 second. I'm going to capitalize all of these initializes. All right, so now that I've created all these, I really wanted those capital. I'm so happy I finally did that. So now that we have our mesh library initialized, when we call mesh library.mesh, it should return that. So our game object should now be the same exact triangle. And to just prove it to you, I'm going to run it and boom. So now that we have that triangle, let's go ahead and create one different mesh. Oh man, you're excited. I bet you've probably already done this. So I'm just going to copy the custom mesh down here, and I'm going to paste it right here, and I'm going to call it quad custom mesh. That's right, we're creating a quad custom mesh. So now that we have our quad custom mesh, we need to add it. So up here at the top, I'm going to create a case for the mesh type of quad custom. And then I'm also going to initialize it upon when the library is initialized. So this will be quad custom mesh. And this will be for dot quad custom. So now back in our game object library, prepare to be amazed when we say quad custom. See how easy that is to change that? See how dynamic that is? This is some freaking cool stuff. Oh, it gets me fired up, data structures. Anyway, this is our quad. Now it doesn't look like a quad, it just looks kind of like a background, but you'll note that it's from this point to this point to this point, and then that creates a triangle, and then this is also a triangle. And to prove that, what we can do is back in our mesh library, as opposed to doing 1, 1, 1 right here, if I just select all of these guys, I think this is how you do it. You select these, and then you do maybe edit. Okay, so that took me a second to find, pun intended, because you go up to find, and you go down to replace and bind right here, find and replace. And that should pop up this guy. Let's replace all the ones with the 0.5. And then do that again, where we highlight them. And if you keep holding Alt and Option, you'll see all in selection, and you can just click that and they should all return 0.5. So it'll be halfway across the screen. I'm going to press play now and show you some cool stuff. So we have a quad. We have a quad rocking on our screen, and that is it. And real quick, just to kind of also show you some cool stuff, under here, under render command encoder, where we're on the game object calling render, let's just go ahead and go render command encoder dot set triangle fill mode to lines. So that'll show the outlines of our triangles as opposed to filled up. So you'll see an actual, like the actual triangles being created. So that's pretty cool. It's like that. That gives you that outline. I'm going to comment that out because I don't need that right now. And let's talk a little bit about other stuff, such as we have a mesh now. So this is separated out. This is decoupled, which is pretty sweet. We can create these on the fly with Quad Custom, but really we need a way to make it so that this is more dynamic. Obviously I'm hard coding this, but we want to be able to change our game object based on something that's passed in. So for the game object, what I'm going to do is I'm going to create an initializer, and I'm going to take in a mesh type. And this mesh type will then be used to create our mesh. So I can just go like so, and boom, boom, boom. That was a weird way of doing it, but it works. I'm going to put this guy at the top. And we have our mesh object being created upon load. Let's go ahead and finalize this by passing in the mesh type as opposed to the hard-coded version. And then wherever we're creating our game object, which is in our renderer right now, we can now say a game object with the mesh type of dot quad or whatever. And I think I have to go mesh types dot quad custom. And now I can create game objects however I want. I can create two game objects of different shapes just by passing in a different parameter. But I do actually kind of want to extend this a little bit more, because even calling game object is a little weird, right? Like, this shouldn't be a game object. We should have this as like a player. So what I can do is over in game shiz, I'm going to create a new file, and I'm going to call that player. Now we have our player class, and I'm going to extend the game object. Now, look at that. I don't need to do anything. It automatically extends it, which means that I can say back in my renderer, instead of doing all this stuff, I could just go game object equals a player. So this is our new player object, right? That we can move around the screen. We can't do it yet, but we need the mesh type. So back in player, what I'm going to do is I'm going to create an initializer, and instead of overriding the initializer, we don't need to do that. Let's just create an empty initializer, and we'll have it initialize itself by calling super.init with the mesh type of, let's do quad custom. You see that? So now when we create the player, it automatically initializes itself with a mesh type. And since the game object holds that mesh, we have nothing to worry about. Let's go back to our renderer. I'm going to actually get rid of this game object aspect because we don't need that. I'm going to build it just to kind of make sure. And we've created a game object. I'm actually going to rename this to player as well, because that makes a lot more sense than game object. And player.render. Press play, and we should see the same exact square. Yep. So yeah, I know I said nodes before. Let's talk about some nodes. So each game object it needs to be a node, right? We need our, we want to create data structures that we can store many, like thousands of game objects that don't contain a mesh. We don't need them to contain a mesh. That doesn't make any sense. It doesn't really describe the node aspect of it or the position or anything like that. It's just the mesh. It's just the shape of the object. And so what I can do is in my game shiz folder right here, I'm going to create a new metal class, and I'm going to call it node. And our game object will then just extend from node, just like so. And I bet it's going to imply, no, it's not, because I have this guy. Okay. So yeah, now our game object's a node, and everything, if I wanted to create an array of game objects, really like here, I can say var game objects, which is an array of node, equals empty. And then I can add to that my player. My player could actually go in here, just like so. See that? You can just create these guys on the fly like that because the player is now a node, right? And then the node doesn't really hold anything. So if I did want to make any calls on it, it wouldn't make any sense because it doesn't have any properties. Unresolved. Okay, that's not an error. It's lying to me. You're lying to me. So back in our node class, let's do some stuff. So back here in our node class, yes. Okay, so in renderer, we have player.render with a render command encoder. We can make this even better also. So since we have a node and we know that our node can render, let's create a render function. We'll call it func render, and then we'll pass in the render command encoder, just like we were before. And we'll do the rendering here. But as of right now, our game object doesn't really have like values that we can use. Like we want to be able to call render on the game object, but we also want to separate this rendering out from the game object because really a game object isn't supposed to render, it's supposed to be a game object. So let's separate this out into something that we like to call in the game industry a renderer. I don't know if anyone else calls it that. I learned that at some point. In our game shiz, I'm going to create a new group and I'm going to call it protocols because we're going to create multiple of these. Create a new file and we'll call this file renderable. This is going to be a renderable, right? And this is going to be a protocol, not a class. Okay. All right. Well, protocol renderable. Now, what I can do here is create a function called doRender and then pass in a render command encoder. Just keep following along. This is going to be good, I promise. MTL render command encoder. And then go back to my game object and extend it, right? Because if you know anything about Swift, we can extend protocols and call them on, and we can do like this type thing. We can find out the type and like generate a new object of that type and call functions on that type. If that didn't make any sense, that's okay. I'll show you. So I'm going to go extension of game object here, and I'm going to do that as a renderable. Now we need to instantiate this class, so I'm going to create this func. Func do render, right? Do render, and let's do everything we're doing up here in here. Since we're a node, we don't need to do that up there anymore. We can do it all down here. If I build, everything works just fine. And back in our node class, we can do the rendering. So the rendering could go a little bit like if let, so we're going to instantiate a variable. So if let renderable equals self as renderable. See how I'm casting it to a renderable? And if this fails, then it won't do anything. It'll just kind of skip over it. But if I am a renderable, I can use this property that I'm creating right here and say renderable dot do render with the render command encoder. Since I cast it as a renderable and it worked, I cast it as a renderable. So if I go back up here, I'm going to put this node on top of this protocols. I'm also going to put this right here, and player will actually, in game shiz, I'm going to create a new group and I'm going to call it game objects. And I'm going to stick that right above protocols, and I'm going to stick the game object and the player class in there just for a little bit more organization. Node kind of encompasses all of this stuff, and renderable is the protocol. So we have a renderable. Really what we could do with renderable, you can create protocol for freaking collidable, right? You can create something that objects that collide. So when you call update, you can say if let self equals collidable, then do a collision, else I'm not collidable, so don't do it. It's really nice for stuff like that. So we're gonna reuse this pattern over and over and over again. But yeah, let's get back into it. Back on our renderer, now we're calling player.render. This is calling the node's render function. So it'll jump into the node render function, which is right here. It'll say if I am currently, so if my game object is a renderable, which it is, then do a render. Else go over. And so now we can store this inside of data structures very cleanly. We can create positions and all sorts of stuff up here in this node. And if I run this, I am assuming I get a freaking square. And I know you're excited about the square. I'm sorry it took so long to get rid of the square. Or get rid of the triangle. But boom, there she is. So back in our game object, you'll notice that we have created this class of game object that extends this, it has this node, implements this node, right? Look at, all we have is mesh now. We're gonna create in the future, don't type this, but we're gonna create like some attributes, right? And that'll be an array of attributes or whatever, however we wanna store that. And then we'll have, you know, our var model constants and all sorts of stuff on the game object, and we don't need to store it all in the node. So this was a really freaking cool way of creating a game object class without storing everything and making huge freaking colossal game objects. We can change this as we'd like from our renderer class. We can now do player, which we can just set that equal to triangle custom, quad custom, all sorts of stuff. This is pretty awesome. I hope you enjoyed it. I'll see you next time.